Thank you very much. My name, as you already heard, Babenko Roman, and let me tell you about myself a little bit. Yes, I'm a software developer and been doing my job for almost 20 years, and I can cut my experience in a half. First 10 years I was desktop developer with Delphi and Firebird and interface databases. And then another, since 2008, I became a software web developer and DevOps. Frankly speaking, that's my very first English-speaking presentation, so it's gonna be challenging for me and hopefully not so challenging for you. I'm gonna be speaking slowly and understandably, but I like to challenge myself. No pain, no gain. So I have not seen snow for last 2 years because I was working abroad in Ireland and Malta as a Ruby developer and DevOps. Today, that's frankly, it's my first pivorak presentation, but not the first I prepared. Previously, we probably can see the presentation about Surf, HashiCorp Surf, which were presented by my friend Andrei Grechko, but all background, all examples and presentation was prepared by me. But as you probably remember, you was told that today I have to do that by myself. And when I was in process, what's gonna be interesting for the auditory? I was asking myself because, as I know, auditory in Ukraine, especially in Pivorak and Lviv, it's pretty different. It's hard to satisfy all of you because some of you are well experienced and they expect something new, something innovative. The other part is just school children, and they probably will not understand what I'm talking about. So, as I was told not once today, that everybody likes stories. So today I'm gonna show you my story of fails, and one story, one fight, how to choose your tools, especially in a team, because as while during my experience, I found most of our problems, it's not technical problems, it's exactly problems of communications. Because our branch, what we doing, it's very young and we are smart. And very often people in a team has a different level of experience and they cannot communicate in the same level. And sometimes decisions we made, they are not objective. For example, when in a team you have one experienced developer and 5 juniors. Of course, and we are pretty democratic, and every time when we have to vote about something, 5 against 1, experienced developer always lose. And that's why it's really important to understand, even for juniors, that we have to trust one another. And despite today, I'm gonna tell you about story of loops. It's a background framework. I'm pretty sure that nobody in this auditorium even heard about it. Because it happened 10 years ago. It was made 10 years ago. But as far as I understand, you like to discuss pretty old things. As I know, lots of people in this auditory is a fan of Elixir, which is just a reincarnation of, tell me, Erlang. Erlang was made 30 years ago. So I cannot say to tell you the story about 10 years old framework. And it exactly makes sense, even not the title of the presentation, but this strange phrase. In English, it sounds thus passes the glory of the world. It means that even if it's something very interesting and new and comfortable, we can lose this because we don't have enough supporters for this tool. So, I'm not gonna blame any frameworks. No Sidekiq, not Resque, not others. All of them are friend, and we have to use it all together. So the picture shows we are friendly. We not blame nobody, but despite these guys. But exactly this guy is a Alexei Koverin. He created the loops framework. It's Ukrainian-born developer. Now, the last time I heard about him, he was working for Canadian company Scribd. At the moment when he created loops, there were no other background jobs, or they were pretty young. There was no Sidekiq even, just Resque. And that guy created the loops to do Scribd. It's a biggest site of documents. They just you can upload documents at the site, and they will give you ability to convert from one format to another and share them. So lots of job for in background. And of course, at the moment, 10 years ago, as I remember my own experience, we had a bunch of cron ruled scripts which were cared about our background jobs. Sometimes it was painful to stop them. Sometimes they started to, they very often were crashed. And that's why loops was really helpful things. Loops help at the moment. What is loops? Loops is just one manager and several workers. And manager cares about workers. And but in comparison to contemporary frameworks, as I know now, Sidekiq is most widespread, right? But Sidekiq Sidekiq is good, but not has some issues. For the beginning, let me introduce you into thread and forks. There are only two. Mostly all the background jobs frameworks are the same, but just different level of isolation. There are only two level of isolation for Ruby framework. As I remember, it's a thread and a fork. But as I remember, there was an attempt to introduce fibers, but frankly speaking, I don't know any production application which uses this approach. So just thread and fork. What's the pros and cons using? You can run job inside whether thread or fork. What is the benefit usage of threads? because threads share memory. Of course, it's a benefit. You save some memory, but at the same time, and it's the problem of the Sidekiq, you don't know who occupied toilet, who exactly consumed all the memory, and it's hard to debug it. And very often it's recognized as a problem of the developers, and it's from my own experience. DevOps blames that developers made wrong code and it leaks. But in fact, it's not leaking of code, it's just the approach how Ruby, especially MRI, consumes memory. When you have memory consuming thread and it consumes the memory, this memory will never be returned back till the moment you restart your application. That's how Ruby works, because allocation memory operation is much expensive than releasing. So if you already consumed some memory, most probably you will need it next time. So Ruby doesn't return it. So it looks like it's a leak, but it's not a leak of memory, and it's not an issue of Sidekiq. And from my point of view as a DevOps, it's not a big deal. I can create a monitoring script to restart that process. But at the same time, so it's a benefit and it's a problem at the same time. Just in case if you don't understand how that happens, it's a just feature of Sidekiq. Of course, if you have a thread, your code is very fragile to failures. Because code shares the same memory, even sick fault can kill all your system. And another problem, you don't know who consumed the memory. And of course, if you develop with threads, your code has to be thread safe. So quality, so efforts you have to provide and devote to development has to be higher. You spend more time because in theory, asynchronous system and the thread-oriented application is faster, but in fact it's hard to debug. And in comparison with thread, forks consumes a little bit more memory. But very often people are afraid to use forks because in fact it's a different process and memory has to be duplicated. And people expect then when you do fork, you increase the consuming of memory because you do a copy. It's true and it's not true in practice, and I will show you why. When you have fork, it's a pretty close thing. So if something happened inside the fork, if something happened in Vegas, it stays in Vegas. So fork, you can just restart it, and then it doesn't impact your processes. But as that happened with threads. And of course, you can spend less time you can even run your not so perfect code inside of fork because it doesn't impact other threads. Why nowadays forks? What happens when new product or new tool comes to the market of the development? They say, oh, you have a problem, we will resolve it. So when Sidekiq came to the market of development, the first killer feature was save your time, and another Resque, which is pretty abandoned right now. Resque uses forks, so that's a. But nowadays, modern kernels Linux kernels use copy on write feature. What does it mean? It means if you fork your process, it doesn't mean you copy all the memory of parent process. Only small footprint. Just in case, if you change something in the fork, the pages from parent process will be copied into your memory. So in fact, you not duplicate it, and this sentence means then if you run to 10 different processes in loops with fork, it doesn't mean that Rails will be loaded in memory 10 times. I see some misunderstanding, so let me show you. Unfortunately, I cannot run that all the examples I prepared for this presentation. You can get on GitHub and run on your own. So I will just show you results. See what happened. First of all, loops, it's a framework which can run both approaches. You can use whether threads, whether forks. None of contemporary framework can do that. So you have to decide every time whether you use Resque or whether or Sidekiq. In Sidekiq you have just only threads. In Resque you have forks. But then here I started 10 different loops processes, and they consumed in virtual machine, and they consumed, as you can see, 600 out of 1 gigabyte of memory. It means most probably to our attention is useful this number. It's something about 62 megabytes. It's exactly the price of running empty Rails applications from scratch. As you can see, if we multiply 62 to 10 processes, we will have this consuming of memory. But that happens. It's just illustration of how fork works if you use different dedicated processes. But if you use loops, approach of loops, you can see that we have almost the same number here. It's 55 megabytes, but memory consumption is dramatically less, almost 6 times. Why that happens? That happens because a manager in loops uses a copy on write approach. So Rails was loaded just once, and other loops, other processes consumed were forked and were not duplicated. Loops provide this example shows us another interesting thing, that even we shouldn't trust our tools. In this case, we use htop, despite we use htop. And even if you use threads, my apologies, sorry. See here, even if we use threads, this is threads. They all have the same size, and you can probably think that we can just simply multiply number of threads to this information, and we will find how much memory was consumed by our application. But the problem is, if I increase this number to 20, you will find that your calculation gonna be bigger than physical memory in your machine. What does it mean? It means that htop provides you wrong information. what is the real information? The real information you can collect, you can investigate code of loops and find how they do that. It's a proc memory, and you have calculate all the chunks which were consumed proper process, but at the same time, loops provide us tool which show us a real picture of the real situations. So you can run bundle exec loops stats, and it will show you real statistical by the, let me show real statistic per process. Yeah, see, this situation is much precise than the previous one. See, real. This is real memory consumed by each loop, each background process, and the total memory is not the 6. Yeah, that is total memory consumed by all the loops. But as you can see, each loop consumes not 50 megabytes as HTOP told us. See, there is a more 100 and even half of megabyte. Okay, go again. Another interesting killer feature of the loops, it's restart. As I already mentioned, the problem of the thread-based background jobs, it's returning of memory. And of course, experienced people, guys can say me, it's not a problem of code, how to return the memory. You cannot restart your application every time. Actually, you can. But at the moment when we were the developer, we were DevOps, and there were no notion DevOps at all 10 years ago. It's a very new situation. You were a developer, you had to care about everything. So, and as less tools you use, the less tools you use, the better. You shouldn't communicate with other part of your team, and you can save some time. This example shows situation. See, this is loops, memory bloating. This is a code which consumes memory very fast. Undeservedly doing a collection of garbage to consume memory faster. This was because this is fork. I know the PID. If I know the PID, I can calculate how many memory was consumed before and after. And as you can see, this part of code, I think this code is pretty readable. This code calculates how many memory the process consumes right now after doing each cycle, each job. And then if this memory more than 600 megabytes, just exit 0. That's one of the killer features of loops. In this case, exit 0 gives a command to manager restart the process. So it means that that process will never consume more than 600 megabytes. And you can see that in log of the process. So see, 500, 600, loop restarted, and then the memory was released. Profit, you can do it. If Sidekiq, you can try it, but you will not succeed at probably. Multiple configs. As I already told you, that the problem of development not only technical, sometimes it's administrative. And because loops support both models of the running of the processes, You can split your code as a trustful and fast and thread safe and bad code. It's like purgatory. You can put it into forks, and you can have two configs. One code is on the bad side, and the other code in the good side. If you have Sidekiq or Resque, you can't do that. You have just only one model, and you cannot isolate your bad code from. You can't prevent it from impacting other part of your system. Just in case. Yes, there are. I know the solution on the DevOps side. You can use containers, you can use control groups, you can use God or monit. But as I already told, the less tools you have, the better. Callbacks. This is a simple code which shows that with loops you already have callbacks. Means before fork and after fork, and you can put your code. This code was taken from a real project where we collected the statistics of one of the approaches, how to find who consumes memory, who behaves wrong way. It's collecting of metrics, so you can use New Relic, and that code exactly does that what you need. And of course, I already mentioned, exit 0 restarts the loop. So if something happened with this code, it will be restarted next time and started from the clean state. Testing. That's one of my favorite topics. Nowadays, I think testing something is even more useful thing than developing, because everybody can develop. You can create a hello world, and you already the developer. But how to test it? Because test it's a solution when test is something which can help. You can build a big system without testing. This system small because our first task is not exactly developing code, but our enemy is the complexity, and exactly test help us fight complexity. And loops provides helpers for testing. It's a simple example. So I instantiate loop, instantiate for instance of the simple loop class, and with create loop helper, and then I expect some behavior from it. So it's easy. Then, but personally, I prefer a little bit different approach. I never test classes, controllers, etc., 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 because in unit tests, because everything you can do in a controller or loop, you can miss. You can pass wrong parameters. That's it. What you're gonna test. So another approach is just move all the logic in separate class, and you can play with it even in console. It's a Rails console. So now the most interesting slide, I would say, it's cases. Why loops? Of course, why loops? Because everybody have their own old things, old shoes, old trousers, etc., etc., because they are comfortable. The fastest way to do something is reusing something you already know. And as I already mentioned, that threads, loops support dual model. It means threads and forks. But unfortunately or not, loops doesn't have a persistent layer. You cannot store your jobs as you can do that for Sidekiq and Resque. But on the other hand, I already mentioned that more or less all the framework is the same. So how to create any framework from loops. If you use loops with threads and we use RabbitMQ, we will get sneakers. You probably know what is that. It's background jobs which processes based on RabbitMQ. So you can do the same with loops. So it's architectural patterns. If we use loops, threads, and RabbitMQ, it's a pretty simple Redis-based queue. We will have Sidekiq, because what is Sidekiq? It's just workers and a persistent layer with Redis to communicate between different workers, and that's it. And small web interface, nothing more. If we use fork engine with loops and Redis queue, well, we will have Resque, because Resque in fact is a fork-based workers and queue based on Resque. And eventually, actually, why I already mentioned that now tips and tricks. That presentation was a kind of as an advocacy when we had a conversation in our project. What we had more. We had about 26 applications which were using different frameworks, and we decided to select one of them. And just people provided all arguments about one framework, another framework, and very often when people sometimes you cannot admit that you are not aware in something. You just argue, and that's the source of most wrong decisions. So this is examples. This is examples how people expected loops works, and that's why they have to get rid from our application. It means for some projects, loops were running as a separate process. As I already showed you, if you run background jobs in several processes, the memory will be consumed, will be duplicated, because manager will be present for each project, and it cannot use a copy and write ability, because each process is a separate process. There is no memory consumed. In addition, if you run the processes as a dedicated, the problem is when they start, they want all of them want to get as much resources as they can. And you will have a spike. You will not have it if you use normal running loops as a jobs, as a group, because manager will care about each loop, and it will be started in a proper moment. You will not have memory duplication, and you will not have spike at the beginning, because manager will start jobs one by one. Probably, yeah. Another problem we faced, it's usage of sleep. Why that happened? Because when you consume some API very often, for example, Facebook, they will throttle you if you do request very often. Site recognizes that as a attack, and they will stop you. So between requests, you have to do sleep at least 1 second, just not to overload your time limit. But Loops has its own implementation of sleep with shutdown support. What does it mean? It means manager cares about. Manager the only object to rule them all. And implementation of sleep with shutdown. This kind of sleep every time checks the state of the manager. If manager in shutdown mode, it just stops to work. But if you use simple regular sleep, manager know the loop, know nothing about state of the manager, and every time manager gives 10 seconds to the process before it just kills it. Because for manager this this process just unresponsible and dead. Normal mode. Another problem you could face with background jobs, it's killing processes by minus SIGTERMI. None of process can resist this command, and they they die every time when you do that. And the last, you probably faced the problem as well when you have something hard, huge job. When your worker is doing something hard and you want to stop it, the job inside still proceed to work. When you kill your process with -9, this job after killing process will still proceed to work, especially hard request in database. So the normal approach is to send the normal approach. Never use -9 with your background process. Never use -9 if you want to resolve some situation with any applications, because you will lose all useful information. Actually, that's it.